It's a beautiful day in this neighborhood, a beautiful day for a neighbor. Would you be mine? Could you be mine? It's a neighborly day in this beauty wood, a neighborly day for a beauty. Would you be mine? Could you be mine? I have always wanted to have a neighbor just like you. I've always wanted to live in a neighborhood with you. So let's make the most of this beautiful day. Since we're together, might as well say, would you be mine? Could you be mine? Won't you be my neighbor? Won't you please? Won't you please? Please won't you be my neighbor?
Good evening, everyone. Welcome to Tibbetts Physics. What is crappin'? Today we are going to talk about the mass energy equivalence. If you could take a moment, and if you have a scale in your house, do you mind massing yourself really quick? I'll pause. Hopefully your scale is in kilograms, and I assume when you massed yourself you got around 20-ish grams or 0.021 kilograms. Okay, well, what if you can, instead of massing yourself, if you can pluck all the protons, electrons, and neutrons that make you, or maybe do somebody else so you could pluck them off them, and put all of those on that scale and mass that. And what do you get this time? Weird. So this time you got like 21 grams. If we took the mass of the protons, plus the mass of the neutrons, plus the mass of the electrons that make you, we're going to get a much, much smaller mass than what the scale says. Let's say the mass of you is around 60 kilograms or 70 kilograms on a scale, and we took the mass of all those protons, neutrons, and electrons that make you, we're going to find that they're a much smaller amount than what the scale says. So we can say that the sum of the parts, that's the protons, neutrons, and electrons, that's what we're made of, is less than the whole, which is you. So something must be going on where if we take everything that masses up to you, and you mass much more than those. Think about a great sport team. If you took a whole bunch of great players, put them together, and they don't have chemistry, they're not going to be as good as they would be individually. So our mass must come from somewhere else. And it was Einstein who came up with the idea of the mass energy equivalence, where mass and energy are interchangeable. And he has this famous equation, E is equal to mc squared, where energy is equal to mass times the speed of light squared. It turns out that most of the majority of the mass of our bodies doesn't come from the mass of the things that we're composed of, but comes from the energy of those. More specifically, the majority of our mass comes from the energy that's creating the protons. We'll talk about the energy in the next video, but it has to do with the subatomic particles called quarks and the energy that's binding those together. So, our mass, humans, our mass comes from energy. What we're going to do next is just take Einstein's equation, E equals mc squared, and come up with a few more units by taking the mass of 1/12 of the carbon atom. So we're going to take E equals 1/12 of carbon 12, the mass of that, times the speed of light squared. So 1/12 of carbon 12 is 1.66 times 10 to the negative 27 kilograms, times the speed of light squared, 3.00 times 10 to the 8th meters per second, quantity squared. And we do that and we get an energy to be 1.49 times 10 to the negative 10 joules. So the mass of 1/12 of carbon-12 is equivalent to 1.49 times 10 to the negative 10th joules. What we could do next is now convert this to electron volts. So we're going to go from 1.49 times 10 to the negative 10 joules, and we'll put this in electron volts. 1 electron volt is equal to 1.60 times 10 to the negative 19th joules. Plug and chug, and we get 9.31 times 10 to the 8th electron volts. We're next going to convert this to mega electron volts. Mega is times 10 to the 6. 9.31 times 10 to the 8th electron volts is equivalent to 931 times 10 to the 6th electron volts. And 10 to the 6 is equal to mega electron volts, or 10 to the 6 is the prefix for mega. So now we could say that this is equal to 931 mega electron volts. And by this, I mean 1/12 of the mass of a carbon atom. And instead of saying 931 mega electron volts, we could convert this to a new unit. And that's going to be universal mass units. So 1 universal mass unit in physics, we just use lowercase u to represent that, is equal to 931 mega electron volts. And again, this is equal to the mass of 1/12 of carbon-12. And that's it for this video. Thanks for watching, and I'll see you next time. See ya!